In this lecture, we're going to show how to use DMU Kinematics Workbench. So if we have assembly, with DMU Kinematics Workbench, we can create kinematics of our assembly. In other words, we can create simulation movements of our assembly. So in our example, we're going to create kinematic movements and simulation of our robotic arm. So here we have 7 parts, and first we're going to create assembly file and we're going to insert those 7 parts. So let's go here to the start, mechanical design and assembly design, like this. So let's go here to the product. Let's go with existing component. Let's insert those 7 parts here. Let's go with open, like this. So here we have those 7 parts. Let's go with a close, and let's go here to the manipulation. Let's go along z-axis, like this. Let's move this one, like this. Let's go with this one. Let's check here with respect to constraint. Let's go with this one here. Let's go with this one here, like this. Let's go with this one here, like this. Here we have this one, and here we have this one, like this. Now we can go along y-axis. We can go with this one here. Let's go with this one here. Let's go with this one here, like this. So those are the parts of our robotic arm. So we have here 7 parts. Now we have to combine those 7 parts, but we won't combine those 7 parts here in the assembly workbench. We're gonna go to DMU Kinematics Workbench. Let's go with OK here, like this, and let's go here to the start. Let's go down here to the digital mockup, and here we have DMU Kinematics. Let's click on this. And now here we can see that we are in the digital mockup kinematics workbench, like this. Here we have DMU Kinematics toolbar, and here we have DMU generic animation toolbar. Make sure that you have those 2 toolbars. If you don't see them, you can right click and you can find them here. DMU Kinematics and DMU generic animation, like this. The first thing that we have to do before we create the kinematics, we have to create a new mechanism. So let's go here, let's click here, fix part. And now let's go here with a new mechanism. Here you can give a mechanism a name. We can go with mechanism 1. Let's click OK, and now let's select this part here. This part will be fixed. So you can go here, here we have a symbol of the fixed part, and here we can see our constraint, fix 1. This is it. Now we have to create the other relations between our parts. So we want that this part here will be in contact with this part here, and that this part will rotate 360 degrees. And for that, we have to create a joint. So in the kinematics, we have to create joints between our parts. So let's go here, we can click on this arrow, and here we have different joints that we can apply to our parts. So here we have revolute joint, prismatic joint, cylindrical joint, screw joint, spherical joint, planar joint, and so on. So here we have a lot of joints, and in our case we're going to use this one here, revolute joint. Let's select this one. Now here we have a new dialog box. Here we have the mechanism, and we have only mechanism 1. Here we have the joint name, revolute 1. So here we have to make selection, line 1, line 2, plane 1, and plane 2. So we're going to go to this cylinder. We can see here this axis. Let's select on this cylinder. This is the line 1. Let's go here to this cylinder of the part 2. This one here. Let's click here, and this is line 2. Now we have to select 2 planes that will be in the contact. So let's select this face. As we can see, plane 1, and this face here, plane 2. This one here. Here we have option angle driven, and we want to make sure that our joint will be angle driven. Let's check this one. Let's go with OK, like this. And now here we have a message, the mechanism can be simulated. Let's click OK, like this. And now let's go here to the specification tree. Here we have a constraints that we added, fix, coincident, and offset. And here we have applications. Let's open this. Mechanisms, let's open this, mechanism 1. Let's open this, and here we have joints and comments. Let's open joints. So here we have our one joint, revolute, and here we have a comments, comment 1. So this is the comment for rotating this part here. So now we can go here to the DMU Kinematics, and here we have an option, simulation with comments. And now here we have comment 1. Now here we can move this to the left and to the right, and now we can see how we can rotate our part 2. Like this. If we want to go to the initial position, we can go here with reset. Like this. Let's close this. And now we're going to create the joint between the part 2 and the part 3. But before we do so, we want to make sure that here we have the right orientation. So let's go here to the mechanical design, and let's go to the assembly design workbench. Let's go here to the manipulation. Let's go rotation around Z-axis. Let's rotate this like this. And now let's rotate this one like this. And here we have the good orientation. This is good. Let's click OK. Let's go back to the DMU Kinematics. Here and here. Like this. Let's go here with the second revolute joint. Here. Let's select this cylinder for the line 1, as you can see here. And let's select this one here for the line 2. For the plane 1, we're going to select this face. And for the plane 2, we're going to select this face here. And let's check here, angle driven. Let's click OK. And here we have the message, the mechanism can be simulated. Let's click OK now. And now here we can see, here we have 2 revolute joints, as we can see. And here we have 2 comments. Now if we go here to the simulation with comments, now here we can manipulate with 2 joints. This one here, as you can see, and this one here, like this. Let's go with reset. Let's close. And now let's go with the next part. Let's go again here to the revolute, like this. Let's go here, and here for the line 1, let's select this cylinder. Let's go here to the other side, to this part, and let's select this face here for the line 2. For the plane 1, we're gonna select this face, like this, and for the plane 2, we're gonna select this face. Let's check angle driven, let's click OK. And here we have the message, the mechanism can be simulated. Let's click OK. Now again, here we can see we have 3 joints, and here we have 3 comments. So if we go here, now here we have 3 comments, which we can use for the manipulation, as you can see here, like this. Let's go with reset. Let's close. Let's add the next part. Let's go to the revolute, this one here. Let's select this face here for the line 1, and let's select this one here for the line 2. For the plane 1, let's select this one here inside, and for the plane 2, we're gonna select this one here. Let's go with angle driven, let's go with OK. And the mechanism can be simulated, let's click OK. Now here we have 4 joints and 4 comments. Let's add here the next part. Let's go to the revolute. Let's select this face here on this cylinder and on this hole. So this is line 1 and line 2. For the plane 1, we're gonna select this one here, and for the plane 2, we're gonna select this one here. Let's go with angle driven, and let's go with OK. The mechanism can be simulated, let's go with OK, like this. Now as you can see here, we have 5 joints and 5 comments. And let's go with the last part. So let's go to the revolute, like this. Let's get closer. Let's select here this face for the line 1. Let's go here. Let's select this face for the line 2. For the plane 1, let's select this face, like this. And for the plane 2, let's select this face here, like this. Let's go with angle driven. Let's go with OK. And mechanism can be simulated. Let's click OK. And this is it. This is our assembly. Now here on the specification tree, here we have our constraints. Now here we have our joints and our comments. So here we have 6 joints and 6 comments. So you can go now here to DMU Kinematics. You can go here to the simulation with comments, like this. So here we have 6 comments, which we can manipulate 6 joints. So for example, we can manipulate with this one. Now we can rotate, as you can see. We can manipulate with this one here. We can manipulate this one here, like this. Or you can go here, you can put a value here, or you can go in this arrow, you can go up and you can go down, like this. If you want to go to the initial state, you can go here with the reset, like this. Let's close this and let's save this. Let's go with a file, save as. Let's go to the kinematics and animation. Let's save it here. Let's save it as the product 1. Let's go with save. And let's go with yes here, like this. So this is how you can create kinematics of your assembly. In the next lecture, we're going to show how we can create simulation and animation video of our assembly. Now in this lecture, we're going to continue with the assembly that we have created in the previous lecture. In this lecture, we're going to create simulation video. So make sure that you have here DMU generic animation toolbar. Let's go here, let's select this tool simulation, like this. Let's select here the mechanism 1, let's go with OK. And now here we have the kinematic simulation as we had before, 6 comments, and here we have edit simulation. And now here we can define the different positions of our assembly. For example, if we want that this will be our first position, we can go here with insert. And here we have 1. Now we can move our arm to some other position, so we can go here, like this. Let's go to position something like this. Doesn't matter where we go, just change the position. For example, like this. And this will be our second position, so let's go with insert. 2. Now let's move again. For example, here. Let's move it again. Let's rotate a little bit, like this. And this is our third position. Let's go with insert. And now we want to go back to the initial position. So let's go here with a reset, like this. Let's go with insert. And now we have 4 different positions. Here we have interpolation step. Here we have by the default 1. We can change this, for example, to 0.1, like this. Now if we want to see our simulation, we can go here, we can jump to start, like this, and we can go with play forward, like this. And as you can see, this is our simulation that we have created. If we want a slower simulation, then we can go here to the 0.04, for example, like this. Let's jump to the start again, and let's go play forward. And now this is our simulation that we have created, as you can see. If you don't want to see those constraints, we can go here, right click, and we can go here with height, like this. This is much better. And we can also go here and we can play backward, like this. So this is the simple way how you can create your simulation. Now if we want to record this, we can go here to the tools, image, and here we have video, like this. And now here we can record our video, but before we do so, let's go here to the setup. So here we can select the format. Let's go with VFW codec. Here we can select the folder where we want to save. Let's go to the desktop. Here we can select what we want to capture. Document window. Now we can see this one. We can go with the window. We can go with area, full screen, and so on. Let's go with the window, like this. Let's go here to the movie tab. And here we have rate in frames per second. Let's go with 10, like this. Let's click OK here. Now let's start here our recording and let's go play forward. And we can go with stop recording, like this. Now we can go to the desktop, and here is our video, Let's open our video. And this is our simulation that we have recorded, as you can see. And now you can use this simulation for some presentation. If you want to get a smoother simulation, then here you have to play with interpolation step and you have to play with frames per second. So you can go here to the setup and you can change here frames per second. So this is the simple way how you can create kinematics of your assembly and how you can record the simulation.